Hi, everyone. Thank you very much for being here today. I'm Omer Raviv, and I'll go ahead and talk to you about production debugging and all cycles of debugging. So today there will be a few slides, but I'm not a big slides person. I'm more of a demo person. Please do go ahead and write stuff in the chat window, holler at me, ask questions. Tell me what your biggest pain points with debugging are. So just to start off with a little exercise, if you could think to yourself, like, what are the things that you struggle with when you're debugging inside of Visual Studio day in and day out, and write that into the chat. That would be a good starting point for me to sort of make sure that I'm talking about things that you guys actually care about. So a quick introduction, I'm Omer Raviv. I've been working on debugging solutions for the past 10 years now. My starting point in debugging was that I was actually working my very first job as a software engineer. I was working in medical imaging. So I was working on the software that the doctors and the technicians at the hospital all use to operate a CT scanner. And I just remember that being a very frightening proposition. I was, working on very complicated problems that had to do with the 3D box object that represented the space in the patient's body that we were going to be scanning. And every few months, they used to actually take us out to the hospital to actually see how our code is being put to use. And that was a very scary experience for me to be seeing how my code is being used in production, and the production meant an X-ray room in the hospital where there was an actual person going inside of a machine. And I was thinking to myself, well, I really hope that this thing doesn't crash, because if it does, and they have to deliver a double dosage of radiation to that patient over there, they're probably going to want a better answer than just, null reference was not set to an instance of a variable, right? So that was sort of my starting point, and that's how I became so obsessed with debugging and software quality. And I will talk to you today about two products that I've been the creator of and worked with my team on, that we've brought to life. One is the Ozcode Visual Studio extension, that helps you in your day-to-day debugging, and the other is the production debugging. And I'll actually start with production. How do we even address issues that have to do with bugs that didn't reproduce on my machine, but are produced for our customer? So I'll go ahead and skip the introductions and get right to the meat of production bugs, right? It's a well-known fact in the world of software that the farthest away a bug is discovered from the hands of the developer that made the bug, the more costly it is to the organization, right? If I make a bug as a developer and I fix it a few moments later, okay, that has a certain cost because I need to get my paycheck and so forth, but it's manageable. But then if the QA engineer wind up finding the bug, then that is considered to be usually an order of magnitude more costly to the company, because then the QA engineer has to go and write all the reproduction steps and create an organized bug report. And then, I would have to get that reproduction step, say that it works on my machine and it's not a real bug. And then we'd have to arm wrestle over whether or not it's a real bug, et cetera, and end up finding out that he was testing on a different version than me, et cetera, he or she. And then finally, if an issue is found in production, that has several of orders of magnitude even more cost, because now we have to deal with the loss of reputation to our company. The amounts of people that are involved is on the rise. There's DevOps, there's site reliability engineers, there's support staff that have to be brought into the picture, and things are just that's where we get into the building is burning down sensation that we don't like. And the thing too about production debugging is that it's always the trickiest problems, right? We're dealing with errors that are hard to reproduce. They're hard to replicate, because the version of the code that's in production is typically different than ours. And the way that we're doing DevOps, which means that we're nowadays shipping newer versions to production more and more often, which means, of course, that we're moving fast and we're breaking more things. So today's talk will be about how do we move fast and maybe not break as many things, right? Another big sort of change that has happened in the software industry over the past few years that has been a big factor in all of this is, of course, the move to the cloud and cloud native development, right? Today I write a line of code and it's a very short interval of time until I have to actually see that line of code execute on an Azure App Service or a Docker container somewhere out there. And in some ways, that's a big regression, because it used to be that if something went wrong, I could just put on a breakpoint, start the debugger, hit that breakpoint, start stepping through the code and see what's going on. Whereas now, with the move to the cloud, our software is typically built in a way where a user clicks a button on their mobile app or their smartphone, or their web app, their single page application using whatever JavaScript flavor of the month it happens to be today. And then that call goes through microservice A to microservice B to microservice C, and finally an exception is thrown on microservice D. And for me, ultimately, as a developer, to figure out what was that chain of causality that led up to that error, to that exception, is very, very difficult. And of course, there's all these other concerns around code is running in the cloud. There's compliance. How can I even work with dump files when dump could potentially contain very sensitive information? GDPR and data governance laws are becoming stricter and stricter. So that there are many, many factors that are causing concern here. And ultimately, I feel like the way we do production debugging today really is we mostly just rely on logs, right? So in the cloud native world, there's this fancy word which we use, which is called observability. And I think that's a very fancy term for just good old-fashioned printf debugging, right? Typically, what we do nowadays, if we have an issue in production that we cannot seem to reproduce, we'll get a bug report from an angry customer, or hopefully some error monitoring tool will give us an exception call stack that tells us that something went wrong. And typically what we'll do is we'll look at the code, not necessarily be able to understand why that exception happened, dig through all the logs, which is a big problem, because now if we're doing microservices, it's no longer just a problem of finding a needle in a haystack. Now we have several stacks in which we have to extract several needles out of. And then all too often, we'll find out that whatever it was we were looking for isn't there, right? There's nothing in the logs that tell us what the root cause of the bug was. So we end up adding more logs to the code, redeploying the software, sort of increasing the signal to noise ratio of our code, because every other line has to be writing something to the log. And then going through the entire CI/CD cycle, waiting for the issue to reproduce again, reading the new logs, and hopefully after several iterations of this, we'll be able to figure out what actually happened. So the Ozcode production debugger is a product that we built just out of frustration with the way we do troubleshooting in the cloud, of messing with these log files and trying to diagnose issues in such a cumbersome and slow way. And I'll go ahead and jump right into a demo, because I think picture's worth 1,000 words in that regard. And I'll sort of explain what you're seeing as we go along. So I have here the eShop on web, which is the classic Microsoft example of an ASP.NET Core application. And it happens to be running on an Azure App Service right now. And because I really like software bugs, I, of course, introduced a bug into this. So what you're seeing here is that we introduced a buy two, get one free sale for this checkout experience. So I'll go ahead and show you what happened to our customer. What happened to our customer is that they decided to buy this swanky black sweater. And so they hit add to basket. And then they decided they want to take advantage of the whole buy two, get one free sale. So they updated the quantity to 2 and hit update. So far, so good, right? We see that, as you might expect, it does appear as though they're going to get 2 items for free items for the price of 2. But then what happened is that our customer ended up deciding that they don't like the color of this specific t-shirt. So they changed the quantity to 0, hit update. And unfortunately, nothing good came out of that. They got an HTTP 500 error. And what will happen now, and I can guarantee this, is that the customer will not send us an email saying, here are the, something bad happened, here are the exact steps that I took to cause the faulty behavior. They will just move on with their day, and they'll never buy anything from us again. And that's, again, goes back to speak to the cost of production issues. So at its core, what we're trying to do with Ozcode Production Debugger is to solve this issue of reproducibility, of how do I, as a developer, understand what happened here if I wasn't there sitting alongside that person to see the issue. So I'll jump into the production debugger and show you what I got here. So what we're seeing here is that this dashboard shows me all the errors that have happened, and it's showing me the exception that occurred 71 seconds ago. It tells me how many times this exception occurred. And when I actually click on this, it shows me the stack trace of this failed request, but it also gives me a preview of what the actual line of code that threw the exception looks like. And when I go and hit debug, that's when I step into the actual debugging interface. And here I'll pause for a moment and explain how this magic works. So what we are seeing right now is a time travel recording of the code execution flow that led up to this exception. And so what happens behind the scenes is that the way the production debugger works is that the first time an exception occurs, it analyzes the call stack and the flow of code execution that leads up to that particular exception, and turns on lightweight code instrumentation. So it's using bytecode instrumentation or the profiling API, which is typically used for tools that analyze performance issues. Only here we're using it in a new way to give you time travel debugging. And when I say time travel debugging, what I mean is that, as you'll see here, Ozcode visualizes the code execution flow in various ways. It's showing me these adornments on top of the values that show me what was the value of each variable at that particular moment in time. And it's also using colors to indicate meaning. So for example, as you can see here, in the if statements, every expression that evaluated to false is painted red, and every expression that evaluated to true is painted in green. And so if I look at this method right here, I can already figure out that the issue is that when we implemented the whole buy two, get one free sale, it turns out that we did a good job of implementing the logic for incrementing the count, but we didn't do a very good job of implementing the logic for decrementing the count. And so what happened is that we got calculated a new quantity, which is a negative number, as if we're trying to buy a -1 t-shirts. And that's why we got an argument out of range exceptions thrown down here. So what you're seeing here is essentially a debugging experience that's running out of your web browser, that's showing you the exact code execution flow that happened when the bug occurred on the exact version of the source code that was in production at the moment that the issue occurred. And what you're seeing right now is actually the decompiled code. So it won't contain any of the original source code comments that you have, but we are enabling also integrations into GitHub so that you can actually integrate it and see the exact original version of the source code, including all your source code comments. So one more thing I'd like to call out here while we're looking at this visualization checking out all the different types of information that we're seeing here, like all the code that wasn't executed because there was an exception, or in this if statement, the code that wasn't executed because we didn't enter into that branch is de-emphasized for me. I can hover over all the different variables. I can go and check out everything in the locals window. But more importantly, I can collaborate with my colleagues using a GitHub pull request type model of collaboration. So because anyone that is invited into this organization or this debugging experience can see the same thing that I can see here, which is the code execution and all the variables. We can now collaborate and even send point-in-time links. So as you can see here, I collaborated with myself earlier because I'm a very lonely person. And I said, it seems that unit price in the basket was correct. So that definitely wasn't the issue. And here I said, oh, the requested quantity was item.quantity. Now, if I actually click on the different values here, that will highlight the particular value. And I said, we got the Black Friday coupon logic wrong and ended up with a negative number as the new quantity. And when I hit that button, it will go ahead and highlight that faulty variable right there. So I can use these little references to particular values at particular moments in time to indicate to my colleagues, hey, I think that this is the root cause of the issue. Then we can work together as a team to try and get a consensus around what we think was the root cause of the bug and what would be the best possible fix for it. I could also give links to nested properties deep inside of the tool of the locals window here. So you'll see here that when I hover over something, I actually have three options. There's copy to clipboard, that's easy enough. There's a copy link to variable, so I can just get a link to my clipboard and then send it over to my colleague via Slack or WhatsApp or whatever it is we're using. Or I didn't mean to say Slack, I meant to say Microsoft Teams. Please excuse my behavior. I meant Microsoft Teams, of course. And then there, the other option is, of course, that we can say mention variable, which would add the variable link to the collaboration panel. And again, unit price is a variable that is nested deep inside. So when I click that link, it will actually show me this animation, which goes deep inside that nested structure and shows what I meant to say when I said that unit price seems to be correct. So I can even give links to very deeply nested objects inside of the locals window. The last few things I'd like to call out here in the production interface, in the production debugger interface, is if I go to a different exception for a moment, and this was actually an exception that I'm showing you from our website. So the Ozcode website, where we sell licenses to the Ozcode Visual Studio extension that I'll show you in a second, had a bug where our customers that we give free licenses to had the button that says add more or buy more licenses still enabled, and sometimes they would click on it even though they had a free account, and it would crash. It would just give them this weird error that looked very non-professional. So when we reproduced it, we saw you know, exactly what the issue is. As you can see here, we saw the code. We saw that the calculation ended up throwing a not implemented exception because it was on the free subscription payment handler, which doesn't handle the action of buying more licenses. But interestingly, when we look on this example that's from a real website, in this case, our shopping portal, you'll see a bunch of other interesting bits of information. One is that this timeline view above here, above the fold, shows me all the high-level requests that happened that led up to this particular exception. So I can see here the various HTTP requests, like the post that came into the service and any outgoing request that I made with the HTTP client. When I actually click on this one, I can go ahead and view the request and response bodies, so the JSON texts that were passed from hand to hand. Or when I look at the SQL statements, I can actually go ahead and see the SQL that was passed into the database. So that's a really good indication. One of the things that I should mention is that Ozcode Production Debugger also works with all the different APM vendors. So if you're using your New Relic or your Datadog, I think I actually have Datadog hooked to this one. So we support Datadog, New Relic, Dynatrace, all those tools that you might be using for performance monitoring are also supported with the Ozcode Production Debugger. So that even though they use the same underlying technology of bytecode manipulation, the Ozcode Production Debugger knows how to multiplex its bytecode manipulation with the application performance monitoring tools. And so you can use the two side by side without issues. And again, New Relic, Datadog, Dynatrace is already supported, and we are working already on supporting app dynamics as well. One last thing that I'd like to show you here on the production debugger interface is the logs. So when you install the Ozcode Production Debugger agent, one of the nice things that you get for free is integration into whatever logging framework it is you might be using. I won't go into too much details, but essentially what that means is that whether you're using Log4net, Serilog, Nlog, or the Microsoft Extensions logger, you'll see your logs or the last 1,000 log statements that led up to the exception in the production debugger interface itself. So I think that gave you a pretty good overview of how Ozcode is able to show you bugs that happen in production or in your staging or QA environment. And I think that this can also make working with QA folks much easier. We call this the production debugger, but I do feel that it can save you quite a lot of time just in your pre-production environments, your staging, your QA, in your day-to-day work when you're using code that's on the cloud. In terms of how we actually get this thing installed somewhere, if I go to add application, and I just create a demo app, what you'll see here is in order to get the production debugger installed, there's very few things you have to do. Basically, there's an agent that you have to install wherever your code is running. And we support both Windows and Linux, so you can basically have that installed wherever your code is running. If it's an Azure App Service, you'll get instructions to simply go into the site extension gallery in the Azure portal, install the site extension with one click, and you're done. If you're using a good old-fashioned virtual machine that's running IIS or Windows services, that it's just a Windows installer that you hit next into, copy this token, which indicates the name of the application, into that installer, click next, and again, you're done as well. And this also supports WPF and WinForms app, so you can just type in the names of the WPF or WinForms app that you want monitored, and you'll be good to go. Same sort of ease of use with Azure Functions and Service Fabric as well. And for a Linux Docker container, if you're using .NET Core 2.1 and up, or .NET Core 3.1, it's just a matter of copy and pasting some lines of code into your Docker file to get the Ozcode agent set up there. Pete asks a wonderful question that I anticipated. You know my interest. What about Xamarin? So Xamarin, unfortunately, is not yet supported. But we do hope to add support for that in the future. All right. If there are no questions on production, oh, there is one question that came in. Nope, no more questions that I can see. All righty. So we've talked about debugging in production. Let's shift our focus now and talk about our inner loop of debugging, right? We've addressed this issue of we need to get faster results when we're dealing with production. Now, let's turn our attention to what happens in my day-to-day. What happens when I, are just going through the sludge of stepping through code in the Visual Studio Debugger while I'm working on a new feature or a bug fix that came in through QA, and I'm trying to figure out what happened, and I'm not having a good time, right? I find that in order to be truly successful at debugging, To me, I think most developers know sort of innately and intuitively what you have to do. You have to be very rigorous. You have to be very methodical. I call it applying the scientific method religiously, right? You have to form a hypothesis about why the code is not behaving the way that you expected it to behave. And then you either prove or disprove that hypothesis and then move on to the next hypothesis, right? That's the only way to be truly successful at debugging. But the unfortunate thing about being human is that, as developers, is that what happens all too often is that we'll spend an hour and then another hour and then another hour. Sometimes we'll spend days on end trying to solve a single issue, and we'll get so frustrated and so angry, and we'll just want to go home, and we'll be so pissed off. And that's typically where we get into the situation which I call zombie debugging, right? Where we're just mindlessly stepping through the code, hoping that the bug will sort of jump out of the computer screen. We're no longer, being methodical. We're no longer, constantly thinking, what is the thing hypothesis that I'm trying to prove or disprove right now? We're just mindlessly stepping through code and not really thinking straight, right? So the idea behind the Ozcode Visual Studio extension is, how do we prevent that? How do we give you the power to see what your code is doing without having to, do so many steps to sort of appease the debugger to be able to extract out of it the information that you actually want and need in order to solve the bug. So I'll show you a few demos here. And again, I encourage you to ask questions. Tell me what are your pains of debugging, and maybe I'll be able to show you a demo either using Ozcode or the plain vanilla Visual Studio experience that solves your pain. So please do feel free to write on the chat window in Twitch. What are the things that are hardest for you to debug inside of Visual Studio? I'm very curious to know. So for me personally, while you've got your fingers on your Twitch streams, I'll tell you that one of the biggest pain points for me is working with collections. And I find that when I'm looking for a specific value inside of a large collection, I often get very, very frustrated. From the get-go, you see here, I'm looking at a list of customers and nobody bothered to implement toString on customer. So already I'm at a problem because I can't really tell these objects apart. So I go ahead and select, for example, the full name and the ID property with Ozcode. So as soon as I have Ozcode installed, when I hover over the variable, I get the Ozcode window instead of the normal Visual Studio window, which has these stars. The Ozcode stars can also be nested, so I can select the zip code inside the address, and then, which is a nested property, and then select the address inside the customer. And then I can actually see the zip code within the address of each customer at the very top level. So I don't have to open each one individually, which would pretty much take me all day. The other feature that we have in Ozcode is a super fast search. So I can simply search for, let's say, a customer named Michael, hit enter, and it will immediately find that customer, but it will also give me some quantitative information as well. So for example, if I type in, for example, the word female, it will immediately tell me, oh, you've got 12 hits for the word female. Or if I'll change this to the word male, it will immediately tells me you've got 18 hits for the word male. So it's a very quick and easy way to get some quantitative insights into the nature of the information inside of this collection. Now, another type of search that we can do on top of the textual search that I just showed you is a condition-based search. This is very similar to a LINQ where clause, if you're familiar with that. So I get this obj keyword, which basically denotes the current object. I've flipped it over to a condition-based search. And now I can basically type in a predicate. So I can say, for example, obj.firstname.length is larger than 6, for example. And we immediately get this visual indication, which shows me with a red X or a green V, whether or not each item matched the predicate. And you can see that a total of 7 items in this list match the predicate. Again, if I hit the filter button, it will show me only these people with a relatively long first name. So very, very convenient to sort of grok the information that I actually want to know. The next thing you'll notice here is that the same visual indications that I showed you previously in the Ozcode production debugger, they all actually came originally from the Ozcode Visual Studio extension. So we have this annotation on top of the for each loop, which is showing me the current item in the for each loop. And of course, it's showing me the full name and the ID because those are the things I just selected. And you can see here that it's predicting the future in a sense. So I'm about to step into the switch statement. Ozcode is already smart enough to tell me, hey, you're going to go here, not go here. So it's de-emphasizing the irrelevant code. Now, where this gets really interesting is if I have a big complicated if statement like the one I have right here. So again, you see this visual indication. Ozcode is telling me, well, we're not going to go into the else clause, we're going to go into the if statement. And the reason is because these three first sub-expressions return false, but the last one was true. Now, one of the coolest things here is that Ozcode supports this notion of live coding. So I can change the code while I'm debugging, and Ozcode will update this prediction. So for example, I can change this first expression from a not true, not equals, to an equals, like so. And as soon as I lift my finger off the keyboard, Ozcode has immediately updated the prediction. So now it's telling me, oh, okay, so now the first expression is true and the rest of these expressions won't even be evaluated because we have a short circuit evaluation here. And it's really important to understand that Ozcode isn't actually executing any of this code. So if the get yearly earnings method that we see here, for example, has some side effects, like it goes off and it changes the state of some static variable, those side effects won't actually take effect because Ozcode is not actually running your code to show you this visualization. It's only executing a simulation of the code execution using IL interpretation. So with that, let me ask a question. Who here writes unit tests? Write in reach stream if you write unit tests. There, nobody writes unit tests. Unit tests thing is dead, or at least according to the truth stream. Oh, there's one person. There's another person. 2 people, 3 people write unit tests. That's awesome. So I will show you how Ozcode can help you in your testing cycle. And we have a shout out for XUnit and another person that's saying that they're writing a unit test right now while they're looking at the Twitch stream, which is very efficient and very productive. Props to you, sir. So I really very much believe in unit testing, and I believe that one of the most productive ways that you can be efficient at debugging is that once you understand the bug well enough, if you're able to write a unit test or an integration test, or even just a throwaway console app that you're going to throw away a minute later, but something that isolates and reproduces the same bug consistently, then you will have a much easier time actually fixing the bug. Because not only have you got the bug trapped essentially in a room that has no doors and no windows, right? The bug has nowhere to escape, but you also can enjoy the benefit of having that unit test in your CI/CD pipeline, protecting you from a regression, protecting you from having to fix the same exact bug a half a year from now when it creeps back into the system. So the problem with that, and with all unit testing advice really, is that just sometimes it's easier said than done, right? Sometimes we're not really that sure that we're gonna have a good ROI on our time spent writing that test. Sometimes, we get flaky tests. We're not sure exactly how to write tests in a way that is consistent. And so in Ozcode, we have a feature that is supposed to take that sort of laziness we all innately have within us as developers and actually turn it into a good thing. So to give you an example of that, let's say that I've been debugging for 5 hours now, and I try to put a breakpoint here, I try to put a breakpoint there, and eventually after a long time, I find that this particular customer object, this Luis, is the thing that's causing the problem. And I want to go ahead and create a unit test with this particular value. So I'll just right-click it and choose the option of export. What export does is it creates a textual representation of my object, and that I captured from my breakpoint debugging session, and I can have that textual representation as either C#, JSON, or XML. Now, if you look at the C# output, you see that essentially Ozcode wrote out all the code that I would need in order to rehydrate it in a unit test. Now, all I have to do is go ahead and hit copy to clipboard, paste it into my unit test, and I can get up and running much more efficiently. The JSON output is, of course, using JSON.NET. I know the industry standard JSON serializers we all love to use. So you can also just save this to a file and have an integration test deserialize it from a file, or just send it over email to somebody. So it makes things very, very efficient. All right. So another question that I want to turn to the crowd here. Do you guys enjoy using LINQ queries? I know this is another sort of hot topic. Okay, so we have a question. Does the Visual Studio extension play nicely with ReSharper? It does. In fact, I consider myself, I'm the creator of Ozcode, but I also consider myself to be very much a ReSharper power user. And I actually teach ReSharper as well. I think it's a great tool. I know 98% of the shortcut keys. So, and many of my colleagues on the Ozcode team love ReSharper as well. So trust me when I say that if there was a conflict with ReSharper, I would fix it, because I can't use a computer where ReSharper is not installed. It just feels like my fingers don't work, right? So I'm going to read out the feedback that I got on the Twitch stream on LINQ. So people say LINQ is the best. LINQ is great. I use LINQ occasionally until it gets confusing. I like LINQ. The only LINQ I struggle with is join. I steer clear of that one with a cute monkey face. Oh, I appreciate your emojis there, Mr. Aiden, sorry. And now I have to ask you guys another question. Do you enjoy debugging LINQ queries? Dear Twitch stream. Probably I'm not going to get as enthusiastic an answer, right? We only like the writing of the LINQ queries. It's not so much the having to deal with the fact that we wrote them and now they might have some bug. And this is something that I struggle with quite a bit. I kept, oh, and we have Mike R saying, I leave it alone when it works. Or I use LINQPad, which I highly recommend as well. LINQPad is a wonderful tool. But when I'm writing code inside of Visual Studio, I often feel like when I'm using LINQ, I'm essentially making a sacrifice, right? And this will be sort of our banger that we will end with today. How do we make debugging LINQ queries efficient? Because when I write LINQ, I feel like I'm sacrificing debuggability for readability, right? I get code that's a lot nicer to look at, and it's more succinct, more beautiful, more readable. But at the same time, if I have to step over a big LINQ query like this one in the debugger, it either finished or it threw an exception. But other than that, I have no idea what actually happened inside here. And that's a problem, right? And I might be tempted to rewrite this entire LINQ query as just a bunch of for each loops, just so that I'll be able to extract some meaning from it when I'm stepping through code in the debugger. So with Ozcode, one of the features we have is something that essentially turns that equation around, so that the more you use LINQ and the more beautiful, more succinct style of C# programming, it will actually become easier to debug your code instead of becoming harder to debug your code. And let me show you a quick example of how this works. So I have a beautiful poem that I wrote here, and I'm going to sing it out to you. And I'd like you to rate my singing on the Twitch stream from 1 to 10 as I do, because this is going to turn into a what do you call that American TV show where they buzz people off when they sing? So we're going to do that now. So it goes, 99 little bugs in the code, 99 bugs in the code. Take one down, patch it around, 127 bugs in the code. Repeat until no more bugs. So there you go. I hope you appreciated that. I did that every day in the build conference when it was still in person. 8 out of 10, thank you. And some of you might have remembered me there, just drawing in the crowds by having people curious, who is this weird guy singing? That will get you a lot of demos. So in any case, let's see the bug here. So we have a beautiful poem that I wrote, and it's very artistic, as you can see. And I have a beautiful LINQ query that's trying to determine what is the word that appears most frequently inside of this poem. And we already see through the Ozcode heads-up display visualization that we got it wrong, right? This assertion is going to return false. So if I hit step over one more time, I'm going to get this assertion blowing up in my face because we were expecting this LINQ algorithm to return the word bugs, but it's actually returning the word code right now. And if I count it in my head, I see that the word bugs appears 1, 2, 3, 4 times, whereas the word code only appears 1, 2, 3 times. So this definitely should have been the word bugs here. So I'm going to try and figure out why this happened. And so the first thing you'll notice here with the Ozcode LINQ debugging experience is that we get these numeric indicators right on top of the LINQ query as soon as we step to it or hit a breakpoint on it. And these are already really cool, right? They tell me how many items came from each part of the LINQ query. And that's already very useful. But the real magic here sort of happens when I actually click on one of them, right? So right now it's telling me, all right, split, we take the poem, and we split it into words. But when I actually hit the button, I enter into LINQ debugging mode. And this actually visualizes how each item passed through the LINQ pipeline, so to speak. So what happens here is we take the beautiful poem, we split it into words based on comma, space, et cetera, et cetera. So 99 came out a split, passed through the where clause, which returned true, that's why it's green. Then we group by the word itself, and then we order by how many times it appeared in the poem. So 99 appears twice, that's 1 and that's 2. And that's why this lambda expression here returned the number 2. So we order by the count, and then we take the last one because we want the most frequent word, right? Now, inside this LINQ expression, or this LINQ debugging experience, I can actually time travel, and that's sort of a recurring theme here today, time travel to any item and see what happened to it. For example, if I look at the string empty, I see that the where clause returned false, and that's why it didn't continue on to the rest of the LINQ pipeline. Or if I go and examine the where clause, I can decide if I want to see the before or after of the where clause, right? Do I want to see the 79 items that came into where or the 29 items that came out? And of course, when I'm looking at these guys, the red and green indicators on the right-hand side there tell me whether the predicate returned true or false for each one of these items. All right, so that's pretty cool. But we still haven't solved this bug, right? We still don't know why we figured out that it's going to be the word code rather than the word bugs as it should have been. So I'm going to do one more thing here, and I'm going to open up the LINQ analysis window, which I do by clicking the button right here. And the LINQ analysis window is essentially a visualization that allows me to look at the flow of the LINQ query as a diagram. So it's actually an incredibly powerful tool for sort of seeing the execution flow. So I can sort of go back and forth throughout the different LINQ queries, the different LINQ operators rather. And what I'm seeing here, so right now I'm sort of zoomed in on the group by clause. And on the left-hand side, I'm seeing all the items that came into group by. And on the right-hand side, I'm seeing all the groups that came out. And of course, this diagram is fully interactive, so I can essentially click anywhere I want and sort of see what went where. Now, the only thing that I really know about this bug is that it had something to do with the word bugs, right? So I'll just go ahead and type in bugs, hit enter, do the Ozcode search, because search is something we have in all of Ozcode's debugging windows, filter the results down, and now I see exactly what the issue is, right? I see that I've got these free occurrences of the word bugs going inside of this group, but if I click on the other instance of the word bugs, I see that it's going to actually a completely different group. So if you look close, you'll see that we actually have 2 bugs to solve here, right? First, I need to take care of the casing issue, right? I don't care if it's lowercase or uppercase, it's still the same word. But I also need to remove this closing parenthesis at the end that I just forgot about. So, okay, now that I understand the issue, I can just go ahead and fix it. And again, I'm going to fix it using this notion of live coding. So as I change the code to fix the bug, you'll see these numeric indicators light up. So right now, you see that we have 79 items coming out of split, again, because of the open parentheses and closing parentheses. So I'll just add those guys in, like so. And boom, voila, now we have 81 items coming out of there. But the assertion is still false, and the group by is still returning 19 groups because, again, the lowercase and the uppercase instances of the word bugs are still going into different groups. So I'll go ahead and fix that as well. I'll just say here, select I goes to I to lower, and voila. So there we have it. We fixed the bug, and the assertion is now true. So that was just a quick taste of how Ozcode can help us debug LINQ queries. And I should also mention that this works just as well for the LINQ query operator. So let me do another, and then this will be just the last thing for today. I just want to ask you guys, do you prefer the fluent style of LINQ or the query style of LINQ? Which one do you prefer? Please write out in the Twitch stream. Do you prefer to use the fluent syntax, which is the one that has all the lambda expression, like the one we saw in the previous demo? Or do you prefer to use the query syntax, the SQL style syntax that we see here? So please write out in the chat window. So I'll read this out. Fluent, query, fluent, query. Okay. Fluent. So I say 90-ish% of the people prefer the fluent syntax. And that's beautiful because that's what people always say. So I just want to say that I do agree that the fluent syntax, I also tend to prefer the fluent syntax. But I think that there are some cases where the query syntax is actually really preferable. And this is one such case. And maybe I can hopefully convince one of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11-ish people that said fluent, that maybe they should still consider using the query syntax of LINQ at least sometimes. So what this LINQ query here is trying to do is I'm trying to find all the best students in the university. And the way I'm doing that is that I'm saying from each department, I'm using the let keyword, which is actually one of my favorite keywords in the C# language. It's very functional, very mathematical. So I'm using let to define department average as the average grade of all the students within a particular department. So we have math, biology, physics, etc. And then for each student in that department, I'm using where to get just the students whose grade is above average within that department. And then select out the names of those good students. Now, I could do the same exact thing with the fluent syntax, right? Because using the let keyword, as I'm doing just here, is just like doing a select with an anonymous type. And using two froms, as I'm doing over here, is just like doing a select many in the fluent syntax. Again, these are just things that the compiler is translating that to anyways behind the scenes. But I think you'll all agree that probably this up here is kind of, I mean, it's kind of clunky, it's kind of hard to read. Whereas this down here is very clean, very beautiful code, right? It's taking a relatively complicated idea and expressing it in relatively very few short lines of code. And of course, the good news is that all the Ozcode LINQ debugging stuff will work just the same, whether you're using this syntax or that. So you can still go ahead, see using the visualization who are the bad students, who are the good students. You can sort of time travel to each one and sort of see what happened to them. So for example, if I choose Barbara here, I see that in the mathematics department, the average grade was 44.8, but unfortunately, Barbara was not such a good student this year. She only got a 38, so that's why the where clause returned false, and that's why she wasn't included in the list of good students. So again, very, very easy tooling for being able to debug LINQ queries instead of just struggling with them and ultimately deleting them and converting them to for each loops. So with that, I think we covered a lot of ground today. So let me go back to the presentation just to show you guys my beautiful thank you slide. Thank you very much. I'm happy to take any last questions if you have them. Go ahead and write in the chat with stream if you do. Otherwise, I'll go ahead and say thank you very much and have a great day, everyone.